Hi, this is King of Review. Find the points of intersection between y equals 3x plus 2 and x squared plus y squared equals 9. One method for solving this problem is to use substitution. We have y equals 3x plus 2 for the first equation. What we're going to do is substitute the 3x plus 2 into the second equation for y right here. So we get x squared plus y squared equals 9. Notice I left an open space for y. Now I'm going to substitute the 3x plus 2 for y. So that goes here, 3x plus 2 in the parentheses. The next step is to expand this portion. X squared plus 3x plus 2 times 3x plus 2 equals 9. I now have x squared plus, and I'll use FOIL to multiply this portion out, 9x squared plus 6x plus 6x plus 4 equals 9. Now let's combine like terms. 10x squared plus 12x plus 4 equals 9. I want to get a 0 on one side of the equation. So let's move the 9 over to the left. I subtract 9 on both sides. Now I have 10x squared plus 12x minus 5 equals 0. This equation is in the form ax squared plus bx plus c equals 0. When we have an equation in this form, we can use the quadratic equation to solve for x. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac, and this is all divided by 2a. The a, b, and c values come from these numbers here in the equation. So on our equation, a equals 10, b equals 12, and c equals negative 5. Let's plug these values into the quadratic equation. X equals negative 12 plus or minus the square root of 12 squared minus 4 times 10 times negative 5, and this is all divided by 2 times 10. When you simplify, you get negative 12 plus or minus the square root of 344, and this is all divided by 20. So we're going to have two values for x. One will be calculated using this plus sign, and the other is calculated using the minus sign. When we use our calculators to work this out, we get x equals 0.327 and x equals negative 1.527. So these are the two x values that we get. These represent the x coordinates of our points of intersection. The next step is to find the y coordinates of the points of intersection. To do this, we can plug these x values into either one of these two equations and solve for y. I'm going to choose the first equation. Y equals 3x plus 2. Let's plug in our first x value. F of 0.327 equals 3 times 0.327 plus 2, and this equals 2.981. So we have a point of intersection at 0.327, 2.981. This is our first point of intersection. Now let's plug in our second value for x. F of negative 1.527 equals 3 times negative 1.527 plus 2, and this equals negative 2.581. So we have a point of intersection at negative 1.527, negative 2.581. This is our second point of intersection. So letter C is correct. So we just solved this problem algebraically using substitution, but there are other ways to solve this problem. You can graph both of these two equations on your graphing calculator and then find the points of intersection. I'm going to do a rough graph by hand of these two equations so you can see approximately where the points of intersection are. So this first equation here, y equals 3x plus 2, we know that this is a line because it is in the form y equals mx plus b. This is slope-intercept form. So we know it's a line that crosses the y-axis at 2 and has a slope of 3. So let's plot that. Here's our x-axis and our y-axis. Okay, so it crosses the y-axis at 2. So let's put a point here. And it has a slope of 3, which is up 3 over 1. So that would be about right here. Now we can use these 2 points to draw in our line. So here's our line. And now let's look at the second equation. The second equation is x squared plus y squared equals 9. We know that this is a circle because it's in the form x squared plus y squared equals r squared, where r is the radius. So if r squared is equal to 9, we know that the radius is 3. So we have a circle who has a center in the origin, which is right here, and a radius of 3. So it's going to pass through these points because it has a radius of 3. So let's just do a rough plot of what this circle could look like. So here's our circle in red, and our line is in black. And we have 2 points of intersection. We have one right here, and we have another about right here. So the line and the circle intersect twice, and we solved for these points of intersection here. Thanks for watching.